Hey, welcome back to the series where we're building web applications that incorporate AI tooling. In the previous video, we got our application set up and making the first HTTP request to the OpenAI API, but we didn't have quite the best user experience because we basically were waiting until the API completed the entire response and then sent it to the client, and then we updated it. And what would be a better experience, if you have any familiarity with some AI tools, is as soon as you make a request to have a quicker response with text sort of streaming back to the client and updating the UI as the text is generated, sort of applying like a teletype effect. So that's what we're actually going to be working on today using HTTP streams. In order to support the sort of teletype feature that you may be familiar with if you've used any other AI tools, we need to use HTTP streams to essentially stream the text as we are receiving it. But before we get into that, we need to explore something with Qwik.js's specific implementation of these post requests. So if we look at how it works right now, we submit this request, we see that this request is being sent, but we can see that the payload comes back as this sort of serialized data. Now, this is necessary for the Qwik optimizer to know what to do with this data as it comes back, and that's really handy. Unfortunately, it doesn't work for our purposes where we're going to be using streams. In their docs, we do see that the Qwik City team does support streaming responses. However, in order for it to work, it looks like we'd have to use async generator functions, which for me is a little bit too specific to the framework. And I want to make sure that this tutorial is as broadly applicable for whatever framework you may be using. So while we are doing some Qwik specific things, the actual application I want to show is going to be built on fundamentals that you can use across different frameworks and meta frameworks and even programming languages. So unfortunately, the current solution that we've built out relies on this serialized data, which means that we're not going to be able to use essentially the work that we've already done. So route actions are actually out of the question for the project that we're building, which is unfortunate because that means that we won't have access to use prompt action, which gives us all that handy information around the state of the action and the nice progressive enhanced sort of form submission that lets us do all of this information, like if it's running and what the value is. So we're gonna have to actually recreate that, but I think it's going to be a better implementation for learning, and we'll be able to build something really cool. So the question that we're dealing with right now is how we are going to run our server-side logic if we can't use route actions. And I've looked around at different options. And fortunately, the Qwik City team does provide access to middlewares. Now, middlewares are essentially functions that we can inject in between a route handler. And in our case, it allows us to tap into anytime a request is made or specific or requests with specific methods like get, post, put, etc. And the way we use them is essentially by just exporting a named constant with the middleware that we want to tap into. So in our case, instead of using this route action, what we're going to do is actually just tap into the post request middleware. So we're going to say use post, or sorry, on post. And then we no longer need this route action, but we can keep the rest of the body of the function that we had defined. However, we won't have access to form data anymore, but we will still be past the request event. So I'm going to go ahead and just give this a little type annotation just to help us get some auto suggest stuff. And we're going to say request handler. There we go. And for now, I'm just going to comment this block of code out and just make sure that we have this working. So we're going to say console log on post. In these middleware handlers, there's a number of different things that we want to do, but if we want to return an actual response object, what we have to rely on is this request event.send, and this expects a number of things. We can send a status code and some data as we see here, or we can send an actual response object, and that's what I'm going to be doing. So because we want to be working with raw foundational primitives, a response object is going to be perfect for us because that's going to support streaming. So I'm going to say we're going to send a new response. We're going to say OK. And we'll just leave it for that just to make sure it's working. Now, because we got rid of our action, we won't have access to that action anymore, which means we don't have access to this, which means we can no longer use this form, unfortunately, and we'll just rely on a regular form. Now, that also means that this logic and this logic are not going to work, so I'm just going to comment that out for now. I'm going to get rid of this button for now. We're going to add the button back just so we have a submit button, and that's fine. And the action we can leave the same, because by exporting this post here, this is the function that's going to run whenever this route is receiving a post request. And the way that forms work in HTML is if you do not provide an action, they will submit the request to the current route. So that's essentially what we want. But we do want to set the method to post because, of course, this is going to be a post request. So with all that set up, I'm going to hopefully get this right, and we'll have a form on the page that when it submits its post method, it'll trigger this onPost middleware, which will log to the console and then respond with a response of OK. Let's go back to the browser, we hit submit, and sure enough, there it is. And of course, there's my onPost. Now I'm going to reload this page with a GET request, and we're going to get our application back. OK, the next thing I want to focus on is actually building out the stream. So we're still going to ignore this data. We'll come back to it in a minute. But basically, instead of returning a response with just some status, we want to return a response with our actual stream. Now, what is that stream going to be? We're going to build it out, and we're going to do it in a very rudimentary, very basic stream. So I'm going to say const stream is going to be a new instance of a readable stream. And a readable stream constructor takes an object that has a start method that provides a controller. And it's trying to auto-suggest that for me, but I'm not going to do that. So the start method is the function that's going to be run when the readable stream is created, and the controller is the tool that is responsible for basically enqueuing data into the stream over time. So if you're not familiar with streams, I'm not going to go too far into it today, but essentially a stream allows you to send chunks of data over a certain amount of time, and we're going to be using the controller. It'll make more sense as we actually write this out. So what is our readable stream going to do? Well, let's look at a number of different things. I'm going to start with, I don't know, we'll do some, it's going to print some lyrics over time. So we're going to do lyrics is an array, and we're going to have ground control to major space and Tom, period. Those are going to be my lyrics, some excellent David Bowie lyrics, obviously. And then I'm going to create a function. I'm going to call a function called sing, and it's going to say const lyric is going to equal lyrics.shift. So we're essentially going to mutate the array and take the first thing out of the array. So we're going to grab that, and then we're going to pipe that information into the stream. So we're going to say controller.enqueue, and we're going to enqueue the lyric. And then, of course, we need to have some sort of closing condition or finishing condition to close the stream. So we're going to say if the lyrics.length is, I don't know, less than or equal to 1. So on the very last one, we want to do something. We're going to say controller.close. Otherwise, we're going to set a timeout, and we're going to call this, we're going to have this sing function reference itself. So it's kind of recursive, and we're going to give that after 1,000 seconds. Now that, of course, is creating the function. We also have to instantiate it. And so this is going to essentially, every 4 seconds or until this array is empty, it's going to 1 second at a time sing the lyrics. Now we have the request event sending a new response object whose body is this stream. So now let's go back here and let's go ahead and submit this and see what we get. And we do get this back as ground control to Major Tom. That took 4 seconds or so. Of course, this is not the behavior that we want because this is using the default browser behavior, and we really want to do this with JavaScript so that we can take advantage of the stream. After all, a stream just by the browser is not going to be super helpful. It's going to take those 4 seconds, wait until it completes the stream, and then it's going to return the total payload. And we want to get those as they come in, so we'll rely on JavaScript for that. Now, in order to do that, we are going to have to play around with this form. Essentially, we want to intercept this form's submission and deal with it in JavaScript. So you may be familiar with some JSX syntaxes where we can say on submit, but notice how we have a little funny $ thing here. And I'm going to explain what happens there. But let's start with this and just try doing a function here. We're going to say event. And then you might want to try something like event.prevent default. And we'll just start with that. Now we do see a little red squiggly. That'll make sense, but I want to actually show this off. Even though the prevent default is there, we'll notice that it's not preventing the default behavior. We're still doing that navigation. And that is going to be specific to Qwik. So once again, calling out the things that are specific to Qwik so that you can account for them and run them differently in your application. But if you are dealing with Qwik, the reason this is a problem and the reason why we have this fancy $ here is because the Qwik optimizer doesn't attach event listeners synchronously to the page. It waits until a user is going to potentially make an action, and then it's going to go and download the JavaScript to perform that action. Now that's all nice and handy, but that is an asynchronous event, and to do things asynchronously with events, you essentially cannot execute synchronous actions like event.prevent default. Fortunately, the Qwik team does provide a solution to this. I'm just going to move that down, and we're going to say prevent default, and I'm going to look for the submit, prevent default submit. And that's all we have to do. I'm going to make this a little bit cleaner. Prevent default, okay, move that, and there we go. So just putting this attribute prevent default means that we'll prevent the event submission. And then we still can't call it here, but we can console log something like submit. Or actually, let's do something more handy and look at the event. Okay, so now we reload the page, we submit, we see that we're not getting the page refresh, and we do see in the console we have a submit event, and that's great. Okay, so I'm going to create the logic of the function that's going to essentially handle submitting this data. So we're going to call this handle submit, which is not defined yet. And then somewhere up here, I'm going to go ahead and define it. I'm going to say const handle submit is going to equal, and then we'll call this the function. So this is going to be a submit event, and it's going to do something with this submit event. So I'm going to say const, const the form is going to be of type HTML form element, and this is going to be the event.target. And then we essentially want to submit this form. Now I'm going to pull this into a separate function that I can reuse elsewhere, because submitting a form with JavaScript is a very sort of reusable bit of logic. So we're going to create something called a function called JS form submit, which takes a form element. So HTML form element, great, and does something with it. So this is where we want to create the HTTP request that's going to handle submitting the form and getting back the response object with that stream. I'm going to say const URL is going to equal a new URL object that comes from the form.action. So that's going to be the URL that we are submitting the form to. If it's undefined on the form, it'll default to the current page. We'll say const form data is equal to a new form data object, which only needs the form to give us a lot of goodies with having access to all of the data in the form based on the inputs. Then we'll say const search parameters equals new URL search params, and I can pass in the form data, although it's going to complain about that, but this actually works just fine. I don't know why that's always a problem. Then I'm going to say const fetch options. I'm just going to give this a little bit of a type of parameters with fetch, and grab the second index in there. Why is that complaining? Oh, that should be type of fetch. Perfect. And then this is going to be an object with method. Oh, whoops. Haha, missing this equals. There we go. Method. Cool. And we're going to pass in the form.method. So this is also going to inherit from the form that we're passing in. Now, a little bit of logic here. We're going to say if the form.method is .to lowercase is equal to a post method. So only in the case of a post request do we want to actually set the fetch options.body to something. Now, we're either going to set it to this form data object or the search parameters object. If we set it to form data, it's going to set the browser is going to inherently set the HTTP content type to multi-part form data, which we want in this case, but we may not want in other cases where JS form submit is going to be used. So we're going to first detect if multi-part form dash data is already set to, oh, whoops, that's not what I want, is if the form.enc type is already set to multi-part form data. If it is, then we can go ahead and safely use the form data object as the body of the request. If it's not already defined as multi-part form data, then we should fall back to what the default browser behavior is, which is a wwwx URL encoded something, but not going to get too specific. We can just use the search parameters object instead. So for multi-part form data, it's safe to use form data. If it's not multi-part form data, safer to use a search parameters object. That's all we're saying there. And in the event that it is not a post request, then we can assume it's a GET request. So we can just set the URL.search to actually just equal this search parameters object. Okay, that's most of the logic for this. We're of course missing the one thing, which is to return the fetch request that is going to fetch the URL from the form and pass the fetch options that we have defined above. So that's basically the URL, the JS form submit logic. And now we actually want to use it. So we're going to say const response is going to equal whatever we await from this JS form submit. And we're going to pass in the form object, of course. Now we're using this await keyword, which means this function has to be asynchronous. And then what can we do with this response? Well, let's say, let's just console.log the response.body and see what we get. So of course, something is broken, and this is actually to be expected. I wanted to leave this to explain something because this might be what you would expect to work, where you pass handle submit as a function with an event handler. Unfortunately, this is another specific Qwik thing where you can't define this function and then reference it later. It has something to do with how the compiler is going to treat this code. Essentially, because Qwik has very, very aggressive optimization techniques around lazy loading, we have to do something kind of funny where we can either use this directly in line here, and that would be totally fine. But I don't love the look of that because I like to be able to pull my event handlers up outside of the template. So if we want to do that, if we want to do that, we essentially have to follow the instructions here, where what we pass to onSubmit must be a QRL. So we passed a function, and it's basically recommending that we wrap it with this $ parentheses. So if we go to our code, that's essentially what we have to do. We wrap our function. Again, this is specifically a Qwik thing. So if you're not using Qwik, don't worry about it. But it's going to ask us where this function's coming from, or what this function is. And we're going to be importing it from builder.io.qwik. That should have imported it. There it is, $builder.io from Qwik. And now this should work. So hopefully that makes sense, that I wrote some code that should apply to any framework you're using. but then we do have the framework specific little bit of stuff going on here. However, all of this should now be working fine, I hope. Let's submit that. We do get the network request went out and came back, and we do see that we got a readable stream back from the response. So now we actually want to do something with this readable stream. First, I'm going to add some logic to say, to account for if nothing comes back. So if there's not a response body, we can just return early and we'll submit this request and not have to worry about doing anything with it. But if we do have it, then we need to parse the streaming body here. And the way we'll do that is with using the body's reader. So we're going to say const reader is going to equal the response.body.getReader. And then we need to add some logic just to see if the when the stream has finished. So I'm going to create a variable called process next chunk. Actually, I'm going to call it is still streaming. Is still streaming? Yeah, sure. And we're going to say that's going to be set to true. We're just assuming the body is still streaming. And then this is going to be a weird syntax, so I'm going to get through it and then sort of come back and explain it as we finish. So is still streaming. While that's true, we're going to say const, and I'm going to destructure from the value of await, equals await reader dot read. This is going to parse the next chunk in the stream. And what we get out of that is a value and the status of whether it's done or not. And what we can do with that is let's just console log the value, and then we can update is still streaming is going to be assigned to, if we're not done, then we are still streaming. Okay, let's see what we get now. I submit this and we're going to get some weird values, and we get 1, 2, 3. Might be missing some logic there, but we'll solve that in a minute. But what we get are these uint arrays, which aren't particularly helpful on their own. It's an array of these numbers, but fortunately what we can do is actually turn those into text using a decoder. So those are essentially sent over the wire as some binary chunks of data, and we need to be able to read them. So I'm going to create a decoder here. I'm going to say const decoder equals new text decoder, and then we can say something like const chunk value, that's the chunk of data coming down, is going to equal decoder dot decode, and we're going to decode the value. So that uint array, we are going to decode it using this text decoder in order to get the actual chunk of value, and then we'll go ahead and log that. And let's see what I got wrong here, because something's ground control to major blank. Okay, we have some logic wrong. Let's see, that maybe should have been maybe while it's less than 1. I think that probably sounds right. Submit that ground control to major Tom. Beautiful. That's what we want to see. We also want to get this into our actual application though. So we are dealing with the stream in chunks on the client. That's great. And now the only thing we need to do is really update our front end to show that data accordingly. So there's a couple things I want to do here. I want to have some sort of reactive state for the application to both show while it's running and show the contents when it's complete. And we had that before using the form action, which is really handy, but we're going to have to recreate some of that ourselves here. So we're going to be using a store. So I'm going to say const state is going to equal use store, which is another tool that we get from Qwik. So Qwik has the concept of signals and stores are basically good for essentially complex signals. Signals are good for primitive types, so strings, booleans, things like that. But I'm going to be using an object, so I'm going to use a store, which is going to track the reactive state and update things as the state changes. So I'm going to have a state for if we are loading, we're going to say false. We're going to have a state for the text that is shown to the user. And as this sort of application runs, we're going to update the loading state and update the text as we send out the request and as we get chunks of data. So when this form is submitted, we can go ahead and start the day off by saying state.isLoading equals true, right? Cool. Next, I think I'm gonna have to actually update this to have a little bit of logic in there. If we don't have a body, then we can just say state.isLoading equals false. And otherwise, somewhere down here, after the while loop is complete, so after we get the streaming response from the body, the reader, and we go through each chunk of data as it's being brought in, and then we decode it and we get the value. After we do that whole loop, then we're going to go ahead and update the loading state to false once more. Now we also want to update the text as we get it. And the way that's going to work is essentially, instead of logging the chunk value, we're going to just go ahead and say that the state.text, we're going to plus equals that. So it's just going to append whatever the chunk value is as it comes in, and append the next one and the next one and the next one. So, oh wait, let's go back to our UI, because now we have some data for this. We can get rid of that button again. And now instead of action is running, we can replace that with state.isLoading. And we can return this logic. So instead of action.value, we can actually get state.text. Okay, that returned our application to the state that it was before, but now we should be supporting streams, if I got this correctly. So I'm gonna say, tell me a joke, and of course this is gonna say something different, but we get ground control to Major Tom. Got it, okay, cool. All of that work that we've done is great, but we're no longer using OpenAI. So let's get that fixed again. We have streams coming back. Well, let's look at this one more time. We have our UI, which more or less is working the same as it did before, except that it's taking the stream data from some reactive state. And we are sending an HTTP request to a backend using our form submission. We're using the special syntax for Qwik to allow for adding event listeners. And we are essentially sending an HTTP request, setting the loading state, grabbing the form off of the event, submitting the form using JavaScript. And when the form, or when the HTTP request comes back, we're grabbing the body because we know it's a streaming response. We're grabbing the reader off of the body. We are using a while loop to process each chunk of the data from that stream. And then we are updating the component state. Hopefully that part makes sense. This is the part that's a little bit more interesting, which is the on-post middleware. What this is going to do is anytime that this route receives an HTTP request with a post method, it's going to execute this function. This is going to instantiate a stream, which is going to create an array of lyrics, and then over a set of, for each second, basically, it's going to grab the lyrics from that array and enqueue it into the stream. So it's going to pass that data into the stream as a chunk. After the 4 seconds for each chunk in our array, it's going to close the stream, and this handler is sending the entire stream as part of this response. Now note that we don't have to wait for the stream to complete before this request event is going to send the response. It's going to send this right away, and that stream is going to remain open until the stream itself closes. So I'm going to break this down and into its separate parts, and then we're going to replace it with the contents of our actual fetch request. So we have a section here that is do work before streaming. And then we have a section here that is send a chunk of data. And then we have a section here that is close stream. So the same work that we're sort of doing here, we have some analogous work to do over here. Okay, so the work that we can set up ahead when we create the stream is actually preparing the request and instantiating it. So all of that can come up here into the work that we're doing before we actually send any data. So I'm going to send that there, and uncomment it out. Now we just have this issue of not knowing what this form data is. So we can actually grab this off of the request event. So we can say const form data equals, we're going to await this information. It's the request event dot parse body. So this is the data that is sent in the body. Of course, if we use the await keyword, we have to be using, or we can only use it inside of an async function, and that's fine. And it's just complaining that it's of type unknown. That's fine, I know what it is. All right, and once we send this request, we're going to get this response back. There is a little bit of a different thing that we have to send in the body of the request. We have to let OpenAI that we want to use a stream. So we want it to be stream set to true. And that's going to ensure that the response from OpenAI comes back as a streaming response. Now, the next thing we need to do is actually process each chunk of data, right? So what we're going to do is similar to how we were using fetch on the client side, we're actually going to be doing sort of the same thing. So we're going to say const reader. I'm actually going to go ahead and copy this from down here so we can say, where is it? Here we go. This is more or less what it's going to look like. I'm going to grab the reader off the response body, and then we're going to do the while loop while it's streaming. So we've got our response. We're going to grab the reader off the response body, and then we're going to send each chunk of data. So here, instead of updating the state, we're going to grab the same thing, but we're going to send that chunk of data. And if you remember, the way we do that is with controller.enqueue, and we'll go ahead and do the chunk value. Now, for the time being, before we actually send this, let me see what this chunk value is. So console.log chunk value, and then that is going to be our stream. Let's just close this up and see where we are. We have the enqueuer working. We have different logic here. We are going to need to close the stream. So I'm going to copy this and bring this up here somewhere, somewhere like that, and just comment that out for now. We don't need this. This is old code. This is old code. Okay, so let's check where we are. We create a readable stream. When it starts, we grab the form data off of the request. We instantiate our API or our HTTP request to OpenAI's API. We request that back as a streaming response. And what we get back from that streaming response is the reader in the body, and we create a while loop that is essentially going to loop over each chunk of data as it comes in from the streaming response from OpenAI. And for each chunk of data that we get back from OpenAI, we're going to do something with it. So right now we're logging it and then we're enqueuing it, but we're going to see what this data looks like before we continue. So I'm going to submit this, and then we'll go to the console, and we'll see that we get a whole bunch of funky information coming back. Now, it's important to note that this is each chunk of data that OpenAI's API is streaming back to us. And we can see the structure of this data. Actually, it might even be easier or better if instead of just console logging it, I'm going to say start, and I'm going to do a pipe, and then we'll open up the chunk value, and then we'll do another pipe, and we'll do end and close that. And let's see this one more time. Submit that. And we see, okay, so each chunk of data starts like this. There's the pipe. Then this is the contents of the data. It's a string that starts with data, space, and then an object. And keep in mind that this is an object representation in a string. And then there's one new line character and another new line character, and then we get the end, right? So all of that is essentially the data. So we have to work with just the part that we're interested in, which is not this data colon. It's literally just this line after the data colon space. And there's another one here at the end that represents when the stream has finished, and it's just a string of square bracket done. So essentially what we need to do is grab all of the contents from the chunk data that comes after data colon space. and that's going to grab us the object, and that's hopefully going to grab us this square bracket and done. So I couldn't find a better solution than to use a regular expression. So you're just going to have to trust me on this one. And we're going to say something like const regex, or regex if you prefer, equals, and we're going to open and close that regular expression. And again, we are looking for a string that begins with data, colon, and then a white space. And I'm not sure if it's always there, so I'm going to make it optional. And then I'm going to put a capture group. Now this capture group is going to be any content, because it could be this object, or it could be this string of done. So any content after that empty white space. So we're going to do an empty character indefinitely. And we're going to make this a global search, and that should be it. Now, just so you can see what I've tested this and what it looks like, is essentially we have the string that could have an object, or we have the string that could have done, and it seems to grab what I need. If you want, you can also go to this URL and explore what each of these things does, and it should explain it to you. Now I'm going to be a good citizen of my code and add a little comment here and say, actually I'm going to do a multi-line comment and say that this captures any string after the text data colon space. And just to give it a little bit more context, we're going to say at C. There we go. Now someone can come and easily find this URL and see what it does. All right. So the next thing we're going to do is we have to actually grab that string. So what I'm going to do is say let match equal, we're going to say regex.exec, exec, and we're going to pass it. We have to execute this on some string. And I want to pass it on the string of the chunk value, which is what we were looking at a moment ago, right? That's the chunk value containing the whole thing. We're going to pass it there. Now we're going to have another interesting syntax, because this is a really good example of something that doesn't happen all the time. But essentially, where we saw before, the start and the end, in this case, contains two chunks of data. We have one here and then another one here without another start or end going on. So it's possible that in some cases we just have one. Between start and end, we just have one chunk of data. Or in the occasional case, we might have a chunk of data that contains two data points. So what we want to do is essentially loop over the text that's coming in and find all of the matches in it. So we're going to say while match does not equal null. So while we still have matches, we're going to say const payload is going to equal match, and we're going to grab the second item in the match array. And here's where the logic is going to happen. So at this point, let's just see. I'll put that there. But let's see what this payload actually is. Console log payload. Make sure we don't have the other console log in there. Perfect. Okay, we can close you. I'm going to submit this and look at my... Whoa! Look at all these chunks coming in. I feel like that maybe should have stopped by now, and I gave myself an infinite loop because I'm not closing it. Cool. And okay, always remember to have the closing condition for your loops. So match equals, we're rewriting what match is, same regex, and we're going to execute exec once again on that chunk value. So passing it again will get the next the next match in the regex. And I need to close my terminal and open it up again. Okay, got that started up again. Sorry about that if I accidentally caused you to crash your machine. But yeah, whenever you create a while loop, be sure that you have some way for the while loop to exit. So let's try this again. We should essentially see only this regex for each chunk of data instead of running it infinitely. We can reload this. This is up and running. Cool. Yeah. And I'm going to submit this, and now we'll see what we get. Okay, that's more like it. We see all of the individual chunks of data. We are capturing all of our objects as strings, and we do see this final done string here. So we're going to start with that and make sure that we're closing the stream at the right time. So essentially, we want to just check if the payload triple equals done, then we can close the stream, right? So I think we can just do that. Oh, my auto formatter is not working. Okay, cool. That handles closing the stream. Next, what we need to do is handle dealing with this payload. Now the payloads look like this, a string of an object, and we're not so interested in the entire object. What we're actually interested in is just the data that's coming back. So looking at this, or maybe this is a bad example, looking at, let's say, this one, we can see that the part we're actually interested in this object is not any of this, not any of that, not any of that, just where we get to this choices, which is going to be an array, and the first item in that array is itself going to be an object. And that object is going to contain a delta, which itself is an object, and that object is going to have the content, and that's the part that we're interested in. So they say because they make up everything, that's the content that we are most interested in. So we're going to grab it. So the first thing we're going to have to do with this data is say, let's first turn that string of JSON into an actual JSON object by parsing the payload. Then we can say that the text that we're interested in is going to be that JSON dot, and let's look in here one more time. We have the JSON, we want the choices. We know that that's an array, and we want the first item in that array. Here we go, choices, array, first item in that array. On that object, we're going to have the delta, and on that object, we're going to have the content. So we go .delta.content. So that should be our text, hopefully. And I'm going to go ahead and trust my instincts here and say that we got the correct text we're looking for. So in order for us to pass that chunk of data into the larger stream that we've created up here, the readable stream, which is going to be returned into the response, we have to send the chunk of data, which we have the logic for there. And we can pass that here. Burp, 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 burp. And the data that we actually want to enqueue is no longer this chunk value, but this text. So let's see if we got that right. We're going to submit this. And there we go. If you saw that correctly, we saw that worked. Uh-oh, what do we got here? Oh, we have a small error there. The problem is it looks like this last chunk of data has the delta, but does not have the content. So that's unusual. But I guess we can do this if we have the content. Otherwise, we can just send an empty string. I think that's probably fine. Okay, so restart my dev server. Reload the page. I think it's all working. Yep, looks good. We're going to ask for the joke. It's going to send that streaming, and we're going to get those responses. And we have our loading logic working on the button, and we have the data coming back, and everything is working with streams. So let's look at that logic one more time. Just walk through this so that it makes sense. On the back end, when we receive a post request, this middleware is going to intercept that request. It's going to create a readable stream, which is going to start by grabbing the form data off of the request body and passing some of that form data or the prompt to the OpenAI API. Now, a key thing here is we are hinting or telling the OpenAI API that we would like a stream back. So we're not going to wait for the entire response body to come back here. It's going to start responding right away as soon as they have their sort of text coming back. And we're going to wait for that initial response to come back with the first bit of data. And we're going to grab the reader off of that response, and we're going to create a loop. So as each chunk of data comes back from OpenAI's API, we're going to grab the value of it. It's kind of a complex object, so we're going to grab a regular expression that grabs the data or the string after the data on that object or that payload. And we're essentially going to grab either the JSON or the string of done. In the event that we have that we get the string done back as the payload, we're going to go ahead and close our readable stream, and that's going to pass on to the response. But in the meantime, if we are not done, then we're going to grab the JSON payload, we're going to grab the text that we're interested in, we're going to enqueue that bit of text into our readable stream, and then we're going to go ahead and pass through the regular expression again until we have no more matches. After all that, we will go ahead and assume that we are no longer streaming. And if we're no longer streaming, we can go ahead and close this while loop, which means that the stream itself that we are returning will close, and that will be sent as part of the response. So get rid of this. Hopefully that makes sense, and hopefully you got it working. And yeah, I think it's pretty complex. Streams are kind of tricky and interesting, and especially working within Qwik, there's a couple of little gotchas, but because we're doing everything at sort of a low level fundamentals, these concepts should apply across any sort of framework that you are using, as long as you have access to the platform and you can deal with primitive streams and primitive response objects, then this should work. Well, hot dog, we got it working. How does that feel? I think that's pretty cool. We covered a lot of interesting things today around HTTP streams and some things that were specific to Qwik, but hopefully also apply to whatever project you may be working on if you're not using Qwik. And I think we got a pretty decent application going now. The only problem is right now we're still kind of using the generic prompt that any user can put in whatever they want. So we want to fix that in one of the future videos, but we won't be doing that in the next video. The next video is actually going to be dedicated to understanding a little bit more about what these AI tools are doing and how they work. So we're going to step away from the keyboard a bit, but hopefully it'll still be fun and entertaining. So if you want to be informed when that video comes out, be sure to hit the subscribe button so you will be notified. And if you would do me a favor, if you enjoyed this video or you're enjoying the series, please hit that like button and go ahead and throw any sort of comments or questions in the section below, and I will get back to you. So until next video, I hope you are enjoying this and having some fun playing with AI, because it is a wild thing that we're doing. So have fun. I'll catch you in the next one.